Let me show you. We will actually be just working with sine, cosine. So let's rewrite this, and this is square root of cosine x over sine x, and then minus square root. This is, of course, sine x over cosine x, like this. And now we can just get a common denominator. Right here, I will just have to multiply by cosine x on the bottom, and of course, do the usual business, multiply that on the top. And then right here, we multiply this by sine x, bottom and on the top. Okay, now this is the integral, and we have one big fraction because they have the same denominators now. The denominator is just square root of sine x times cosine x. And for the numerator, this part, we just have square root of cosine square x, right? And square root and square, they cancel each other out. And usually we put an absolute value around it, but when we're just doing integration, just forget about it. Let's focus on the function part. So right here, we will have cosine x minus, same reason, this is just going to be sine x right here, and we still have the dx. And I believe you guys have no problem of getting to this right here. But how exactly can we get the integration step going? Well, ideally speaking, we want to just use u-substitution, and we'll have sine cosine only, And hopefully there's some kind of function that we can come up with, and we can assign that to be the u, and the du happens to be just the top right here. In that case, that would be so nice, isn't it? So let me just put down what we want right here. Notice this is what exactly we want to happen. I want to pick some function, maybe from this integral, but let's just see. Ideally speaking, I want something so that the derivative of that becomes cosine x minus sine x, right? And well, what exactly should be in the parentheses? Easy. You can just ask yourself, derivative of what is equal to cosine x? And the answer to that is sine x. And the derivative of what will give you negative sine x? The answer to that is plus cosine x. So ideally speaking, if I can have this, it will be pretty nice. But the trouble is, inside here, we have the square root with sine x times cosine x. This right here, it's plus. Well, don't give up, because think about it. This is pretty much like a binomial, and when you square that, you get a squared plus 2ab plus b squared. And you see the ab part. You can actually just multiply them together like this, right? And here is the note I wanted to write it down for you guys. If we have parentheses of sine x plus cosine x like this, and then if we square that, you see, if I have this, I can still assign this part to be the u, and this is still going to work out pretty nicely. And when I multiply this out, I get sine square x plus 2 times this and that, which is 2 sine x, cosine x, which is this part, And then the last part right here is just u plus the cosine square x. And what's the best part right here? We have sine square x plus cosine square x, and that's famously equal to 1. So in another word, this is just 1 and then plus 2 sine x cosine x. And some of you guys might notice this is pretty much from the double angle formula. Yeah, but let me tell you, it's not going to help. Let's just leave it, because I want to see the sine x times cosine x, which happens to be right here. Now, let's make things happen. I will keep this as how it is, and I will have to make sure that this and that are still the same, okay? Hopefully, I'm just going to somehow squeeze this part out without changing anything, right, in terms of the value of the integration, things like that. Anyway, I still have the square root in the denominator, and on the top, let me just keep it cosine x minus sine x dx. And I still have the sine x times cosine x, right? Okay, in order for me to get this, I need to multiply that with a 2, right? So I should have a 2 right here, but you see, this 2 is actually instead of the square root, and it's in the denominator. So to make sure that they have the same value, I will just have to multiply by square root of 2 right in the front. This is just a constant multiple, put it in the front. This and that can be kinetically cancelled out, right? So same thing as at the moment. Okay, next I want to have this one right here. It's okay, I can just go ahead and add a 1 right here. This is positive 1, but just don't forget to minus 1 right after that. 1 minus 1 is 0, so once again they maintain to be the same. Now the best part is that this right here, 1 plus 2 sine x cosine x, it's exactly sine x plus cosine x and then square, right? So let me just write this down. So that's really nice. From here, we can go ahead and say let u equal to sine x plus cosine x, and then you know the deal. du is equal to cosine x minus sine x dx, like that, isn't it? So, as you can see, this right here, I will just put it down here. We have the square root of 2 in the front, the integral, and right here, this part is just du. So let me put down du right here over this part is the u. So we have u squared minus 1 in the square root in the denominator. So square root of u squared minus 1, like that. And how can we integrate this? And the answer to that is we do trig sub. Yes, I know. We start off with trig functions, and then we went back to u, and then we are going back to trig again, okay? Anyway, you can also use hyperbolic trig functions, but let me just do it with a more standard way to do this, okay? So right here, the deal is that I will let u equal to secant theta, and the reason is because we know secant squared minus 1 is going to give us tangent squared. But let's do the usual business, differentiate both sides, so we get du equal to secant theta times tangent theta d theta. So from here, let's see, we still have the square root of 2 all the way in the front, and then the integral du it's this now, so let's put that down. We have the secant theta tangent theta, and let's put down the d theta right here over, okay, as I said, this is u squared, which is secant squared minus 1, and that's pretty much tangent squared, okay? So here we have tangent squared theta, and you do the square root of that, and you pretty much just have tangent theta. Once again, square root square, just don't worry about it, just cancel them out without putting the absolute value down. Anyway, here's the best part, because this and that cancel each other out. So in another word, we are ready to integrate. We have square root of we have square root times the integral, and this is just the secant theta d theta, and we know the answer to this, which is something you have to remember, right? The standard result, ln, and now you put down the absolute value, okay? When you actually integrate, you put down the absolute value. ln, absolute value of secant theta plus tangent theta. And we're pretty much done, but we just have to go back to the u world first, and then go back to the x world, and that's it. So let's see, how can we get back to the u world? I will still have the square root of 2, I will still have the ln, I will still have the absolute value. Let's look at a right triangle from here. U is equal to secant theta, so I can write this down for you guys. I'll just put this down on the side. We know that secant theta will be equal to u over 1, namely coming up with a right triangle for you guys. Here is the angle theta. Definition of secant is hypotenuse over adjacent. And based on this, we know the opposite is just square root of this square, which is square root of u squared, and then minus 1 squared, which is just 1, like that. Okay, secant theta is just u over 1, which is just u. And then we are going to add it with tangent theta. It's this over that, which is just square root of u squared minus 1. And I still have to maintain the absolute value because this is smaller than that. So if u is negative, the whole thing inside could be negative. So I need to have the absolute value so that wouldn't ruin the ln function. And finally, I just have to go back to the x world. So what is u? Well, let's look back. U was this guy, right? So here we have square root of 2 times ln absolute value. U is sine x plus cosine x, so let me put that down. Sine x plus cosine x, this is for the u, and then we add it with, we open the square root. Well, what's u squared? And as you can see, u is equal to this, and we have done this to the second power already. So let me just write this down for you guys to make this super clear. U squared minus 1 is pretty much just whole thing right here, namely 1 plus 2 sine x cosine x, but then the minus 1, I still have to do that right here, right? So 1 minus 1, which is 0, so that's good. So u squared minus 1 just 2 sine x times cosine x, and perhaps this now, I'll just shorten it by using the sine of 2x for it. And with that, I will just put that down right here, sine of 2x. That will be the u squared minus 1 right here. And we are all done. So we can put down a plus c.